Welcome to Temple Builders Carpentry. Temple Builders. We problem solve with Temple Builders Safety First. Okay, Temple Builders, today we talking about soils and foundations, okay? So anytime you're getting ready to build, particularly a foundation, okay, you want to understand your building site. You got to have so much information about your building site, and you got to have information about your soil. Your soil is very key, okay, to building the foundation. Okay, so there's basically 4 types of soil. Okay, that the ASTM, American Society of Testing Materials, classify. Okay, gravel, sand, silt, clay. Okay, those are 4 types of soil. Now you can put organic matter in there as well. Okay, however, the most stable material to build on would be bedrock. If you look at my whiteboard right here, okay, right down here, this is bedrock. Don't pay attention down here yet, okay? Look at my drawing, my design right here. This is a tree, right, that's going into the soil, all right? This soil can be sand, gravel, silt, clay, like I said. And also, right here, this O layer, that stands for organic matter, all right? So this top layer right here, or top soil, this is your O layer, okay, which is organic matter. As you move down through the soil, you go through different layers, okay? I got them labeled right here on the side. You got an A layer, a E, a B, and a C, okay? Now, in engineering, I'm not a soil engineer, but in engineering, they will call these layers basically horizons. Okay, so this would be your soil horizon, your O horizon, your A horizon, your E horizon, your B horizon, okay? So right here, your O horizon dealing with your grass up here, okay? This is where your tree coming out at. Okay, this is where you have animal products, animal byproducts, you know, animals gotta use the bathroom, things like that. You got your leaf litter up here on the O horizon, okay? You got microorganisms, you got insects, you got whole systems up here in your O horizon, okay? And let me talk about soil for a minute. Soil is composed of 45% minerals, okay? An example of a mineral would be calcite, okay? Gypsum, iron. You got different minerals, okay? Halides, silicates, okay? You got all types of minerals, okay? So soils are composed of 45% minerals, 5% organic matter, and also approximately, 25% water, 25% air, okay? Those are 4 components of soil. I'm gonna say it again. You got about 45% minerals, 5% organic matter, okay? 25% water, 25% air, okay? So when you're getting ready to build, okay, a general contractor would be having conversations with his foundation engineer, with his architect, with his soil engineer, okay, or geotechnical engineer, okay. And usually what they'll do first is they'll go and get a soil sample from the building site. This was gonna give them the components, and they're gonna analyze that soil so they can get an idea of the dynamics of that soil, okay. I believe it's called a bore. They would get a bore sample. All right, so these different layers, okay, the old layer, organic layer right here, okay, it is thin compared to the rest of your layers. Look how thin your organic layer right here is. It stopped by right here, okay? And plus, soils are different in different locations, particularly different climates, okay? You got your wet climate, you got your dry climate, you got your temperate climate. So dealing with all these different climates, your soil type is going to be different, okay? So as you move past your organic layer, you get into your A layer. This would be your, what would this be? This would be organic rich layer, okay? As you move down through the layers, your soil becomes less organic, okay? And I'll give you an example. Look right here in this profile. I dug this hole for y'all to see a little simple profile. of some soil, okay? So if you look right here, you see how dark this layer is right here. This is your organic layer right here, and you can see as you move beyond this layer, go down into your, I would say that I'm not a geotechnical engineer, but I would say this would be the start of your A layer or A horizon. Okay, you see how orange the soil begins to get? This soil begin to change and get orange. To me, that's an indication of clay content. Okay, the clay is beginning to get richer as you move down through your soil. Okay, and if this hole was deeper, you can see the different layers of the soil, and you can go as far as you can reach bedrock. Okay, now simple example or simple way of identifying soil is you can take the soil in your hand. Okay, you want to go past your organic matter right here, or your topsoil. This is also called your topsoil. Go past that and go down into your profile. Now I had this, you see how sticky this soil is? And look at the color of it, like that tan color and almost orange color right there, okay? So, and look, it's sticky. See? A simple way to identify if your soil is sticky, see how it's rolling up into a ribbon? See, it's sticky, so this would be dealing with a high clay content. See that? That would be this soil is pretty high clay content. So clay would be sticky in your hands. And if you had soil, see this part of the top layer right here, you had soil, you gotta put water on it first. Put water on it and then check it. And then if you rub it, if it's gritty, then of course that's sand, okay? Also, if it's smooth, would be an indication of silt, okay? And you know how gravel look, but you can tell that this has a high clay content. How high, I don't really know, okay? But it's folding out into a ribbon, okay? So what happens is your organic matter and your clays start to percolate or filter down the soil, in the soil, okay? And the clays are going to be deeper. Your organic matter, your clays, your carbonates, and also your soluble salts will percolate down through the soil, into the soil, okay? And depending on the texture of the soil and also the soil components, texture is dealing with the size of the soil, you know, whether it's going to be silty clay. And from my analysis of this soil, this would be a type of silty, not silty, but sandy clay type soil. You can do simple tests to find out your soil content, okay? Another little test you can do with the soil would be getting a masonry jar. You can get a masonry jar, okay? Get samples all around your building site, okay? About four locations. Put that dirt in your masonry jar, okay? Put your little dish detergent in there. That's gonna help the particles slip and then find its position, okay? And the sand will settle first, then the silt will settle, and then the clay will settle next, okay? Give it about a day or two to all settle, and you can use a marker and then mark off that masonry jar to find your layers and get a percentage of how much of each soil you have basically around your location. That's just a simple way of finding out soil content. All right, now let's come back up here. Okay, I'm trying to speed through this. All right, now if you look right here, let's talk about the foundations. Okay, depending on what type of soil you have, that's going to determine what type of foundation you can build. Okay, like I said before, I think in my previous videos we talked about clay soil. Clay is a very unstable soil to build on, okay, because it expands and contracts, okay, the dynamics of the clay soil. So if you had clay soil, you might want to build deep foundations, okay? Now, basically, it's two types of foundation that you'll be dealing with. One is a shallow foundation, and the other ones are deep foundations, okay? This is an example of a shallow foundation, okay? This is a spread footing. See a spread footing? And what you're gonna use a footing for in the soil, and this, if you look at this line right here, this is a drawing of, okay, the grade or the ground, all right? And this will be your foundational wall right here. This will be a foundation that'll be used residential homes, okay, light commercial, something like that. All right. So the footing here is because that's going to distribute the weight of your foundation. Now, foundation is for the load of your home or the structure. Foundations transfer the load of the structure to the soil, okay? And the soil has a certain amount of soil bearing capacity. Soil bearing capacity, all right? So let's say, for example, clay. Clay might have a soil bearing capacity, or clay's soil bearing capacity may be around 2,000 pounds per square foot. Okay, 2,000 pounds per square foot. And you can move on up as you get to silt and sand, it'll begin to be heavier. Because when you're dealing with these different types of soil, you're dealing with the soil sizes, okay? So clay is real fine, okay? It's a real fine type soil, smaller, okay? Then silt is a bigger grain, a bigger particle. Then you move up to sand, that's even larger. And as you move on up to gravel, you know, that's even bigger. And so depending on the size of your grain or your soil particles, that's going to determine how the soil drains, okay? So that's why you'll use gravel, okay, as a good drainage material, okay, because of the voids in the gravel, okay? We're going to move on. Now, this would be considered a spread foundation, okay? You got foundations like this, there's a spread foundation. Also, I don't have here is an example of a raft foundation, okay? Maybe I'll do that next time. But yeah, this is a spread foundation, something like this. This is another type of foundation. This is a pile or a friction pile, okay? See, it's not hidden bedrock. If you look right here, this is bedrock, see this bedrock? This friction pile is using the soil for stability, okay? So the surface resistance, okay? The surface resistance of this friction pile and the soil is what's holding this structure up, all right? And as you move on, this is a caisson. This is a caisson pile, all right? Which you see, this caisson pile is hidden bedrock. So this is gonna be stable. This is what something you will use maybe for a sky rise, or what you would call a skyscraper, you know what I'm saying? Bigger commercial buildings, industrial buildings. You wanna hit bedrock with those large buildings, okay? Now, since you're a carpenter and you're gonna be dealing with, well, we focus here on this channel, mostly residential, right? I wanna show y'all these basic or simple types of residential, mostly residential or light commercial foundation, okay? These are section drawings, okay? So this would be called an inverted T, okay? This would also be considered a shallow foundation, okay? Something like this caisson pile would be considered a deep foundation, okay? But this right here basically be used for residential, okay? Right here you have, this is an inverted T foundation. This will be very common, all right? You can see it looks like a T. When a section drawing is just like if you had a pound cake and you cut that pound cake and got you a slice out, and you look at the layers right there from that angle or from that perspective. Okay, that's basically what a section drawing is. This is a section drawing. I'm cutting it open so you can see. Okay, so this is an inverted T with these footings. And what the footing does, the footing basically lightens the load on your soil, because see how the footing is wide? So the footing is taking all the load, okay, and spreading it out, giving you more surface area, okay, which is going to put a lighter load on your soil, okay, so you don't tip the scales with your soil. Because if you got the wrong foundation in your soil, it can settle unevenly, and that's what's going to cause the whole structure to start to buckle. You're going to be getting large cracks, and then your joists, your rafters and everything is going to start to twist, and you're going to have a lot of problems when your structure starts to settle unevenly. So that's the major component from this video. You got to know, when you're dealing with a certain type of soil, you need a certain type of foundation, okay, for that soil. Because Another thing I want to tell y'all about is when you go down in your soil, you also have groundwater. Okay, you got groundwater when you go down in your soil. You got to be aware of that. You want to be a general contractor, you want to be a temple builder, you want to be a carpenter. Okay, a lot of this stuff technical, I know, but you got to know all this. Okay, you will have groundwater in this soil, and you also have your frost line to identify. All right. And also what you got to identify when you're going to build on the site, you got to identify the vegetation or the trees that's on the property. Okay, because you know those trees have roots. Those roots are going to be sucking up water too. Okay, so that's going to affect your soil. That's going to affect the dynamics of your soil. These are all the things you got to take in mind when you're dealing with soils and foundations. Okay, I don't want to take y'all too long because I can keep on going about this. Okay, on and on and on. Okay, so basically this is what you got to keep a memory of when you get on the building site. Okay, go through these layers in your mind. You gotta visualize this. Go through the layers. Okay, hit bedrock. It's your most stable material to build on when you're finna build a structure. Bedrock. Okay, then you go through the soils. Okay, all right. If you like this content, hit the like button, subscribe, hit the notification bell, become my apprentice, Temple Builder.